Deep beneath the Pacific Ocean lies one of the most mysterious places on Earth, a massive underwater canyon, so deep and dark, most machines can't even reach it. Nearly 11,000 meters deep, it is the deepest place on Earth. A crushing void where pressure exceeds 1,000 times what we feel at sea level. No sunlight, no warmth, and yet life exists. But the mysteries don't end with biology. What lies at the bottom of the world isn't just life, it's power. As nations look to the ocean floor for rare earth elements, mineral-rich nodules, and untapped energy, this deepest part of our planet has become more than just a scientific wonder. It has become a geopolitical prize. And one nation is racing ahead of all others, China. While the world looks up toward space, China is looking down, into the abyss, deploying deep-sea robots, building underwater bases, and moving swiftly to uncover and claim what may lie hidden. So, what exactly is concealed in these depths? How was it discovered? And how many humans have ever dared to visit this extreme frontier? This is the Mariana Trench, the deepest, the darkest, the most mysterious trench on Earth. The infamous Mariana Trench sits like a crescent-shaped scar at the bottom of the Pacific Ocean, a 2,550-kilometer-long, 69-kilometer-wide fracture that plunges into unimaginable darkness. It is the deepest part of the ocean floor, part of a global system of deep gouges that silently stretch beneath the sea. These immense trenches were born from a powerful geological process called subduction. In the case of the Mariana Trench, the Pacific Plate is slowly being forced beneath the smaller Mariana Plate to its west. This violent descent carved open the trench and gave rise to a chain of volcanoes that built the nearby Mariana Islands. And the scale of this underwater canyon is staggering. It stretches across the Pacific for over 2,500 kilometers, roughly the distance from New York to Denver. At its lowest, the trench falls into a zone few dare to enter. This is the Hadal Zone, named after Hades, the underworld of Greek mythology. A fitting name for a place of pure darkness, bone-crushing pressure, and acidic, near-freezing water. Here, the pressure is so intense, it's the equivalent of 90 full-grown elephants pressing down on every fingertip-sized area of your body, from all sides. Food is almost non-existent. Life, for centuries, was believed impossible here. For most of human history, it was thought to be a dead zone, an unreachable void, too deep, too dangerous, too alien. But everything was about to change. In 1875, the crew aboard the HMS Challenger cast a weighted sounding rope into the Pacific and realized they didn't have enough rope. They hadn't expected a location so deep. What they had found was a hidden pit within the trench, a place we now call Challenger Deep, the deepest known point on Earth's seafloor. But simply knowing it existed wasn't enough. In 1960, 85 years after its discovery, two men set out to descend into this alien world. Swiss engineer Jacques Piccard and U.S. Navy Lieutenant Don Walsh, sheltered only by a cramped steel submersible called the Trieste. Their 5-hour descent into darkness was dangerous. The pressure outside their small sphere was nearly 1,000 times greater than at the surface. As they neared the bottom, a loud crack split through the vessel. One of the viewing windows had fractured under the immense force. Their time at the seafloor was limited to just 20 minutes. But what they saw in those moments would shock the world. Life. Not just bacteria, but small pale shrimp, even a flounder-like fish, and a strange brown ooze covering the seafloor, filled with microscopic organisms. For over 50 years, no one returned. Then, in 2012, filmmaker James Cameron made the journey solo, diving to Challenger Deep aboard the Deep Sea Challenger. He captured high-definition footage, collected samples, and revealed new microbial life forms. Down there, in a sunless world, life survives without sunlight. Instead of photosynthesis, larger organisms rely on chemosynthesis, a process in which bacteria feed off chemicals released by the rocks, creating the base of a deep-sea food web. Even in the planet's most extreme abyss, life found a way. Beneath crushing pressure and absolute darkness, among mud, rock, and silence, life still endures. Strange, adapted, and often giant. In this extreme world, gigantism is not unusual. It's an evolutionary response to cold, high pressure, and scarce food. Meet Alicella gigantea, the supergiant amphipod. While most amphipods are barely a few millimeters long, this deep-sea scavenger can grow up to 34 centimeters. Its shallow water relatives scuttle unnoticed, but here, size is survival. They are joined by giant isopods, distant cousins of the common pillbug. These armored giants can reach over 50 centimeters, resembling creatures from Earth's ancient past. When food appears, they gorge themselves, then wait weeks or even years to feed again. One isopod in captivity once survived over 5 years without eating. Their size allows them to store energy, move efficiently through viscous water, and conserve oxygen. All crucial traits in a world where resources are rare and survival is a waiting game. Among the most astonishing survivors is the hadal amphipod Hyrandelia gigas. Living beyond 10,000 meters, it should not even have a shell, yet it does, protected by a layer of aluminum armor extracted from the mud using special gut chemistry. Even more impressive, H. gigas produces a cellulase enzyme capable of breaking down wood into sugar, and it becomes even more effective under pressure. An enzyme designed not just to survive the deep, but to thrive in it. And they're not alone. Remote submersibles have captured glimpses of holothurians, or deep-sea sea cucumbers, including the squishy but resilient sea pig, feeding on microscopic debris. Some scientists now believe that the fish seen by Pickard in 1960 was likely a sea cucumber, as true fish rarely survive beyond 8,000 meters, where bone begins to dissolve under pressure. Yet one exception exists. The Mariana snailfish holds the title of deepest living known fish, found at 8,000 meters, still over 2 kilometers above Challenger Deep. And then come the true oddities, xenophyophores, giant, single-celled organisms nearly 20 centimeters wide, tunicates that anchor to trench walls, waiting to strike passing prey, hatchet fish with bioluminescent camouflage vanishing into the glow. Gigantism, bioluminescence, armor, and enzymes that shouldn't exist. These are not the creatures of science fiction. They are very real, living in the most hostile habitat on Earth. So, what else could be in these trenches? We know life survives, but there's still so much more we haven't seen. After decades of scattered missions to the Mariana Trench, one nation is taking a different approach, China. While others sent rare, expensive expeditions, China is building infrastructure. deploying fleets of submersibles, establishing underwater stations, and investing heavily in deep-sea exploration. But why? Because what lies down here isn't just strange, it's strategic. The trench holds cold seeps, where methane and hydrogen sulfide leak from beneath the seafloor. These oases support ecosystems that thrive without sunlight, offering models for future energy systems, and even hints at how life might survive on Europa or Enceladus, moons of Jupiter and Saturn. Nearby, white crystals embedded in the mud reveal something more volatile: methane hydrate, also called fire ice. It forms when methane gas is trapped inside frozen water under immense pressure. It can burn, and scientists are studying it as a potential fuel of the future. But the risks are enormous. Disturbing the seabed could trigger underwater landslides or release methane, a powerful greenhouse gas. And then there are polymetallic nodules, potato-sized rocks littering the seafloor, rich in cobalt, nickel, manganese, and copper, metals essential for batteries, electric vehicles, and renewable energy. To collect them, robotic vehicles scrape the seabed, sucking up the top sediment layer. But in doing so, they unleash vast clouds of sediment, or plumes, which can smother fragile habitats and drift for miles. Another plume of waste is then dumped back into the ocean. Scientists warn the damage could be irreversible. Some areas may take centuries to recover, if they recover at all. Entire ecosystems could be destroyed before we even discover them. We've barely explored this hidden world, and already we're putting it at risk. In our race to extract its resources, we overlook what the deep truly offers: a mirror of life's resilience and a reminder of nature's genius in its strangest forms. These creatures don't just survive in the dark. They clean our oceans, support food chains, and hold answers to questions we've yet to ask. But like the forests we've cut and the species we've lost, the deep may soon become another chapter in humanity's long history of destruction. Did we make this world better today, or worse? China isn't alone. The United States, Russia, Japan, and other nations have all sent missions into the deep, each driven by a mix of science, ambition, and resources. But this isn't about who gets there first. It's about what we risk losing if we're not careful. The ocean doesn't speak. Its voices are silent, its creatures hidden. But they matter. Many species have already been lost to warming seas and changing skies. But we are not too late. A better humanity doesn't just fight for its own future. It fights for every life form that shares this planet, because they are not separate from us. They are us. Today, NASA searches the stars for another Earth, because one day, this one may no longer be fit for life. But this destruction is not nature's doing, it's ours. And no matter how many planets we may discover in the future, none of them will matter if we never learn how to protect the one we already have. The deep is not a frontier to conquer, it is a wonder to protect.